Hello everyone, this is Dr. Indradeep Kumar, Assistant Professor, IARE, Hyderabad. So this video topic is problems on distribution of shear flow. So means our lecture topic will be what? Problems on distribution of shear flow. So how distribution of shear flow is there? That numerical. Okay, so question is, a singly symmetrical thin-walled closed section beam is built in at one end where a shear load of 10,000 Newton is applied as shown in figure. So this is the figure, right? So here, okay. Calculate the resulting shear flow distribution at the built-in end if the cross-section of the beam remains undistorted. Means cross-section of these beams are same, it's not getting distorted, it's not changing. Okay, by the loading and the shear modulus G and wall thickness T are each constant throughout the section. So G and T are throughout its constant, and even after applying the load also, the cross-section is not getting changed. Okay, a thin-walled two-cell beam with the singly symmetrical cross-section shown in figure built in at one end where the torque is of 11,000 Newton meter is applied. Right, so here along this you can see the 11,000 Newton meter torque is applied. So along this one, that was force, load, shear load, and here this is the torque. Now assuming the cross section remains undistorted by the loading, determine the distribution of shear flow and the position of the center of twist. So here again we have to find what? Distribution of shear flow and the position of center of twist at the built-in end. The shear modulus G is the same for all the walls. So shear flow will be constant for both the walls, means all the walls. Okay, so just see the question here. For this part, the thickness is given as 1 mm, right? For this, thickness is given as 1.7. So means 2 to 4 thickness is 1.6 mm, 3 to 2 is 1 mm, 2 to 1 thickness is 1.2, 5 to 6 thickness is 1.6, 4 to 5 that is also thickness of 1.2, and this distance is of 125 mm, that is passing through the center. So this is 1.125 mm, is this also will be 125 mm, and this will be 150 mm. Okay, this distance is given as 300, this is given as 250. Now what we have to find? We have to find distribution of shear flow and the position of shear, so that center of twist. Okay, so now just see again the same question. Now first shear flow distribution. So first we have to what? Apply the shear flow distribution. So just see here along this one. So 1 to 2, 2 to 3, 3 to 4, these directions just see here, right? Then Q4 to 5 and Q5 to 1. Okay, this now we have to find. Given torque as 11,000 Newton meter, shear load of 10,000 Newton. Now just from the figure find the tan alpha, right? So now tan alpha will be what? 125 by, or just here you can see this is 125, right? This is given as how much? 300, right? So this angle we can find, that angle as alpha. So alpha will be what? Adjacent, that this one. Okay. So 125 by 300. So tan alpha equals to, or simply tan alpha equals to 125 by 300. So alpha equals to tan inverse of 125 by 300. That gives how much? 22.6 degree. Okay. So now we found the angle of this one, right? So this side also it will be same 22.6. Since the wall of the beam section are straight, the shear flow in each wall is constant. So because all walls are straight, it's not curved, so all will be same. That will be constant for in each wall, because choosing O, the midpoint of the wall 4-2, right? So midpoint of the wall 4-2 as the origin, right? So taking this point as the origin. So from where whatever we will calculate from this point. Then Q as the origin. Then Q will be equals to, this is what? Shear flow distribution formula. So Q equals to GT into P d theta by dz plus du by du by dz cos psi plus dv by dz sin psi. So now for phi 1. So what we had seen that d theta by dz, what we are writing that as theta dash. Similarly du by dz as u dash and dv by dz as v dash. Right. So that we will use here in the same. Earlier also we had seen two types of problem. Just here the figure is different. Right. So now just for Q51 what happened? Okay. The this u term will be 0. But because of this one. So now finally what we have 1.6 g, that value is given, and p is 250 theta dash plus v dash. This one. Right. This total length is 250. So 250 theta dash plus 4. This sine, this is 90. Right. So sine 91. So dv by dz, that is v dash. Now for Q12, 2. Here what happened? V will be 0. Right. And u will be there. So 1.2, that thickness tg. So 1.2 is given thickness for this one. So g into how much this is given? 125 theta dash minus u dash, because half of this is required. Right. Similarly for Q3, now here that angle will be there. So Q23 thickness is given as 1. So 1g into 125 theta dash into that angle. Right. That only will be there. So theta dash into cos 22.6 degree minus here all are at angles. So no one will be 0. So minus u dash cos 22.6 degree minus v dash sin 22.6 degree. Now here we have to put the value of sin 22.6 degree, cos 22.6 degree in this one. Then we will get Q23. So after putting the value, what we will get? Q23 as 1.0 g into 115, that 115.4 theta dash minus 0.923 u dash minus 0.384 v dash. So this is for Q23. Now similarly Q34 will be what? Similar in this way. Q34. Right. So that also you can say, just see it's a symmetry, so that will be also same. Right. So Q34 will be equals to what? Whatever the Q23. So 1.0 g 115.4 theta dash plus 0.923 u dash minus 0.384 v dash. And let's see here Q12. Okay. So in this case, just see here, just so the difference is here, it's coming negative in this direction. So now we are going along this direction, so that becomes the positive. So Q45 will be 1.2 g 125 theta dash plus u dash. So from equation 2nd and 5th only the direction will be there. And Q24 will be 1.6 g into minus v dash. So now what we have all the shear flow distribution. Now the thing is, we have to find theta dash, u dash and v dash. Just substitute in all the equation, you will get the value of shear flow. Now to find that value, what? Q1, Q2, Q3. So first we will find Q1, Q2, Q3. We will substitute here, and then we will find theta dash, u dash, v dash, and then after getting the theta dash, u dash, v dash, again we will substitute back in these equations. Nice. From 1 to 6. Okay. So now just see, from the antisymmetry Q12 equals to Q45 and Q23 equals to Q34. Thus from equation 2 and 5, that is Q12 and Q45, or equation 3 and 4, u equals to 0. So just equate these two, or just see here. From 5, what is 5? Okay, Q45 equals to, so this will be equals to 1.2 g into 125 theta dash plus u dash. That should be equals to what? 1.2 g into 125 theta dash minus u dash. Right, after multiplying what happened? What we will get? 1.2 g into 125 theta dash minus 1.2 g u dash. Okay, that is equals to 1.2 g 1 into 125 theta dash minus 1.2 g u dash. So this will get cancelled. After bringing this, what happened? We will get 2 into 1.2 g into 125 theta dash is equals to 0. So from here theta dash will be equals to what? Sorry, u dash. That is u dash. So u dash will be equals to 0. Now we got the u dash value from equation what? 3 and equation 1 point this one. Q12 and Q45. Now what we can say? Q23 and Q34 equate. Q23 and Q34. Right? Q23 and Q4 both are equal. So now next is what? Q51. So just see here. Resolving forces vertically. Now what happened? Taking a moment. So first resolve force vertically. Okay. And then substitute back what we did earlier. So for Q51 into 250, just see the figure. Q51, how much is given? That 250. So Q51 into 250 minus Q24 into 250 minus Q23 into 125 minus Q34 into 125 equals to 0. So from here one equation what we will get? Q51 minus Q24 minus Q3 equals to 0. Right? So Q23, okay, that we know. Q24, previous it's given Q51. Substituting in equation 7 for Q51. Right? Q24 and Q3 from equation 1, 6 and 3 respectively gives. So from here, just after finding these value, substitute there. So what we will get? V dash equals to 79.41, theta dash equals to 0. So from here, what we will get? V, okay, this as. Now, taking moment about, so already U dash got 0. Now V dash is what? That is from here is equals to minus 79.41 theta dash. So now two things required. Once we know the theta dash, we can put here, we will get the V dash also. So for that, what we are taking moment about O. So 2Q12 into 250 plus 1, 2 into 120. So this is force into moment, or just see here. Okay, plus 2Q23 into 300, force into perpendicular distance, moment. Force Q51 into 250 into perpendicular distance. That is given that how much moment is there, that will be equal, right? Whatever the moment will equal, that will be of that one. So 11,000 kilonewton is given. So 11,000 into 10 to the power 3. So after simplifying this, what we will get? Q12 plus 1.2 Q23 plus Q51 equals to 176. So now one equation is here, right? Just substituting in equation 9 for Q12, Q23 and Q51 from where? From 2, 3 and 1. Those values are there. So just these values, right? Substitute here. From the same, substitute here. Now, because now two unknowns are there, because U dash is 0, so you can just put 2 dash. So now, after substituting here, you will get one equation. Substituting here, these values, you will get another equation, two unknown. Just solve. So from here, after solving, what you will get? Theta dash as 0.294 by G. Now, once we have the theta dash, substitute here, we'll get the V dash. So, what will be the V dash? V dash is after this one minus 23.37 by G. So, now we have U dash, theta dash, V dash. Okay. Now, just substitute here, right? From equation 1 to 6, you will get all the values of U dash, theta dash. So, wherever U dash will be there, because U dash is 0, so this term will be 0. Theta dash, you know, put here, you will get Q12. V dash, you have, put theta dash, you will get this one. Similarly here, that cost 22.6, we have to just put into the calculator. Theta dash we found, V dash we found, U dash is 0. So this term will be 0. Here, theta dash we have, U dash is 0, V dash we found. So by just putting in all from 1 to 6 equation, what we will get? We will get the value of the C. So how much value we will get? Q51 as 80 Newton per meter per mm. Q12 is equals to Q45. Already that is there because of symmetry. So 44.1 Newton per mm. Q23 is equals to Q34. That is 42.9 Newton per mm. And Q24 is equals to 37.4 Newton. Sorry, 37.4 Newton per mm. So now all the shear stress distribution value Q12, Q5, that Q125, Q524, like whatever is there, that we found. Now the second question is what? The center of twist. Okay, the center of twist referred to O as coordinate. What? That's XR and YR. So XR is what? Minus dV by dz divided by d theta by dz, and YR is du by dz divided by d theta by dz. So now we have d theta what? Or simply you can say XR is equals to dV by dz is this minus dV by dz is V dash, d theta by dz is theta dash, and YR is what? U dash, du by dz is U dash and theta dash. So in this case what happened? U dash is 0, so 0 by theta dash means YR will be 0 and XR will be what? Just now we got the V dash theta dash value, that will, okay. So XR will be equals to V dash value, so minus V dash is 23.37 and by 0.294. That is here. That is, so XR will be what? 79.5 mm. So the coordinate of this will be what? 79.5 comma 0. Okay. So this will be the solution. So this type of question already we had seen. In that, what we have to do? First, shear distribution will be there. Then write the shear stress distribution with the particular angle or whatever is given with this angle. This general equation. So after that, whatever the member is there, how many members are there? 1, 2, 3, 4, 5, 6. 6 members are there. Means 6 equation will be there. That's why we are getting 1 to 6. Earlier, in previous question, 5 members was there. In one case, 4 member was there. So 4 equation. Right? So after finding all the 6 equation, what we have to do? Just apply the symmetry condition and then find the value of what? Q12, Q23 in terms of theta. Right? Then here, let's see the relation between Q12 and after taking, I will just resolve the forces vertically and then take the moment. So from these 2 equation, that another 2 equation will be there. Already we found that from the symmetry U dash is 0. After that, what you have to do? Just substitute the value of whatever is there, that Q51, Q24, Q23 and all. Right. Then solve those 2 equations. Substitute Q U dash as equals to 0. Now you have 2 equations. This equation and this equation. And unknown is also 2. Just substitute the value and solve. So after substituting and solving, we got this value. So theta dash as this one and hence V dash is this one. So now after finding U dash, theta dash, V dash, just substitute from equation number 1 to 6 to get the value of all the shear stress distribution. After finding what? Next we have to find the center of twist. Where is the coordinate? So XR will be minus V dash by theta dash and YR will be U dash by theta dash. So U dash is 0. So this will be 0 and XR will be how much? That after putting the value 79.5. Hence 79.5 comma 0 will be the coordinate or position of the center of twist. Okay. So if you have any doubt regarding this derivation, you can just comment on the video or you can contact me. Okay. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.